Discriminant. After working with the quadratic formula a little bit, we find that we get different kinds of solutions. And a close look at the quadratic formula, we could see that it really comes down to a question of what kind of number we have inside the square root in the quadratic formula. Because of that, we give it a name, we call it the discriminant, and it determines what kind of solutions we get. Let's start with negative. In the case of a negative discriminant, that means that we're trying to take a square root of a negative number. For example, if the discriminant turned out to be negative 15, then our solution would have a negative 15 inside the square root, which, as we know, is not a real number. In this case, we get imaginary solutions. We will get two of them, because in one case we are adding an imaginary part, and in another case we are subtracting the imaginary part. So if the discriminant is negative, what we end up with are two imaginary solutions. It's more accurate to say that we end up with two complex solutions with non-zero imaginary part, but since that takes so many more words to say, we will stick with calling it two imaginary solutions. Next, we can consider the case where we have a positive discriminant. If the discriminant is positive, then our solutions are going to be real numbers because we'll be taking a square root of a positive number. So we will get real solutions in both of these cases. If it's a perfect square, for example, the square root of 64, then we see that the number comes completely out of the square root, and our solution will not have any square roots left inside it. In this case, we would get rational solutions, and in one case we would be adding this number, in the other case we would be subtracting this number, so we would end up with two rational solutions. Now, if that number is not a perfect square, like for example if we have the square root of 10, then we can't get the square root out of our answer. So our final simplified answer is still going to have a square root in it. And that means that my solutions are going to be irrational. I still have two of them because in one case I'm adding the square root of 10, in the other case I am subtracting the square root of 10. So here I get two irrational solutions. Keep in mind that both rational and irrational numbers are real, so in both of these cases we get two real solutions. The only case left is where the discriminant is equal to 0, which means that we end up with the square root of 0, which does come out of the square root and give us a 0. So we're going to have rational solutions because we are able to get rid of the square root. However, what we need to consider now is what happens with that plus or minus. The way this 0 shows up in the formula looks like this. It's going to be minus b plus or minus 0 over 2a. Note that it doesn't really matter whether you're adding 0 or subtracting 0. Both of these are the same. And because of that, we don't get two solutions. We really only get one solution, which is equal to minus b over 2a. And that is a rational number, so this is the only case where we get one solution, and that solution has to be rational. So without actually finding the solutions and knowing exactly what they are, we can tell what kind of solutions we have. There are situations in which it might be sufficient to just know what kind of solutions we have without knowing what the exact numbers or the exact values of those solutions are. So we're going to get a little bit of practice using the discriminant to look at equations and determine what kind of solutions and how many we have without actually going and finding those solutions. Classify the number and type of solutions by calculating the discriminant. For each of these, we're just going to find b squared minus 4ac, which in this case is going to be 5 squared minus 4 times 2 times 4. This is equal to 25 minus 32. So my discriminant is -7. To figure out how many solutions and of what type this equation has, I need to refer to the table that we just put together. I have a negative discriminant, and I see from this chart that a negative discriminant down here at the bottom means that I have 2 imaginary solutions. So that's going to be my answer to this question here. I recommend pausing this recording now and trying to find the discriminant for all of the remaining equations, and then coming back to the video just to compare your answers to the ones that I get. For the second one, or this one to the right, I get a discriminant of 0, and scrolling back up to my chart, I can see that a discriminant of 0 is the only case where we get one solution and that solution is rational. So coming back to this problem here, I'm going to say one rational solution. Looking now at these other two, I can see that in the first one I get a positive number that is a perfect square because it comes out to be 256, which is the same as 16 squared. And in the second one I get a positive number that is not a perfect square. So both of these equations have two real solutions, but in the case of the first one, they are both rational numbers. Two rational solutions. And in the case of the second one, they are irrational numbers because I would never be able to totally get rid of a square root that was on a number that's not a perfect square. So this one would give me two irrational solutions.